अशोक
मिनहास you have raised your hand. Sir, yes sir.
अशोक जी, ओपी मिनहास आपने हैंड रेज किया है, जरा देख लीजिएगा क्या है।
OP Minhas ji, if you want to speak, please go ahead. Your mic is on.
Thank you very much, Mr. Shaw. Good morning. Actually, your voice was not coming. I just wanted to convey that. Thank you very much. Now it's fine. It's fine. Thank you.
Okay, I'm keeping your mic mute, sir. But whenever you want, you can raise. सर बात हो गई सर अभी। नमस्कार सर।
अशोक, am I audible?
Yes sir, you are audible. आप वीडियो भी खोल सकते हैं एक बार सर। Yes sir, it's visible sir.
ठीक है।
हाँ सर, अच्छा है सर।
Okay, thank you. Vinay, how are you?
Good morning.
Mike.
Good morning, sir.
Morning.
I'm good, sir.
Very good.
This time Vinay has done all the preparatory work,
Sir. That's very nice. Good morning, sir. Morning. Who is speaking?
Sir, Srinivas sir. Sir is link officer of Sunil sir.
हाँ, अच्छा गलती से उनका तो वीडियो कुछ दिख नहीं रहा है, इसलिए मैं कंफ्यूज हो गया। वीडियो नहीं आ रहा है सर।
सर आप ऑन कर दीजिए सर।
ऑन तो है। लॉगिन वन मोर टाइम।
आपका आ नहीं रहा सर।
वीडियो ऑडियो इज देयर बट वीडियो इज नॉट कमिंग। जी
जी।
अच्छा।
Sir, we see member S also join. Sir, if you can test the mic and video, sir. Anyone towards member S office, you have joined. Can you test your mic and video? Vinay, you can also request other speakers to join.
Yes, sir. They are joining, sir.
Okay. Hello. Just a minute, sir. Just a minute. अपने सर. Just a moment, sir. मैं just search कर रहा था. सर आपने सर वो आप एज ए गेस्ट ज्वाइन किए हैं सर. तो आप प्रॉब्लम नहीं है. आप थोड़ा रेज हैंड करें ना सर. मैं नहीं सर, आप जस्ट आप रेज हैंड करो सर. बस रेज हैंड करो. जस्ट रेज हैंड वाला बटन दबाओ सर. आप दिख जाएंगे सर. खड़े हाँ सर, देख लिया मैंने आपको प्रेजेंटर बना दिया सर. ऑडियो वीडियो खोल सकते हैं.
Ashok, I am audible.
Yes sir, you're audible. You're audible sir.
क्या हुआ? मेंबर साहब का वीडियो नहीं आ रहा? ऑडियो तो ऑन किया हुआ है.
हाँ सर, माइक ऑन है.
मेरे ख्याल से कैमरा नहीं हुआ.
May I request member S office to rejoin, disconnect, and or there appears to be some leak or event issue. Member sir.
हाँ बॉस, गुड मॉर्निंग. हाँ देख रहा हूँ. दोबारा ज्वाइन कर लें क्योंकि कुछ क्योंकि लग रही है इसमें.
सर नॉइज है क्या काफी इस पर वीडियो पे?
वो मेंबर साहब दोबारा ज्वाइन कर रहे हैं.
ठीक है सर.
अभी बात हुई है मेरी.
नमस्कार प्रोफेसर अर्जित.
नमस्कार.
Namaskar and welcome. So we are just waiting for more dignitaries to join, sir.
Sure.
I also see Abhijit had joined. Welcome, Abhijit.
Yeah, good morning, sir. Hopefully you can see my video and audio is clear.
Yes, we can speak.
Okay, fine. I'll switch it.
Sir, member S is here, but we are not able to.
हेलो
Sir. The member S video and audio is not there.
अशोक.
Yes, sir.
मेंबर साहब का देखो जरा, ब्लॉक किया हुआ है क्या?
नहीं, he's visible,
हमको ऑडियो आ रहा है लेकिन
he is visible as a speaker, sir. On top itself under presenter.
I can see he is visible as a speaker.
And he is a presenter, so his audio video both are on, sir.
दोनों ऑन है. आपका ऑडियो वीडियो तो किया हुआ है. You are basically a presenter.
एक बार
वो
रीजॉइन
इसलिए कहीं कैमरा तो आपका ऑफ नहीं है? हाँ हाँ हाँ। ऐसा कैसे हो रहा है? बिल्कुल, क्योंकि आप यहाँ पे तो मैं दिख रहा है कि आप सारे परमिशन है, आप तो प्रेजेंटर है।
सर एक बार डिस्कनेक्ट करके कनेक्ट करेंगे तो विल
एक बार और करिए डिस्कनेक्ट करके प्लीज। थैंक यू।
Baburaj ji, you are there somewhere. Can you raise your hand? We'll make you presenter. Baburaj from Nokia. Mr. Baburaj from Nokia, just raise your hand so that. Yes, now you have joined. Baburaj, you are there. Yes, you are already as an.
Yeah,
speaker.
thank you. Thank you.
Thank you so much.
अशोक, आप ये देखिए कि उसके अलावा तो कहीं इसमें गेस्ट में तो नहीं अपीयर हो रहे मेंबर साहब सेपरेटली।
There is one user, sir. I'm making presenter there. सर अभी किया सर, अभी सर को रिक्वेस्ट करते हैं। सो मेंबर सर, अगर अभी आप माइक और वीडियो ऑन करें सर। नाउ यू आर, लेट्स सी। Sir, if you're able to hear us, kindly unmute yourself. Haq sir, member S sir.
किसी और नाम से तो नहीं कर रहे हैं?
तो वो मेंबर एस के तो है सर।
हाँ वो तो है, देख रहा हूँ।
अगर वीडियो ऑन करें तो पता लग जाएगा सर। तो 2 जगह से ज्वाइन किया है सर ने।
हेलो,
यस
मेरी
सर,
आवाज आ रही है?
वी कैन सी यू सर।
अच्छा ठीक है, आवाज आ रही मेरी?
हाँ सर, आवाज भी आ रही है सर।
चलिए ठीक है, थैंक यू।
Sir, I think everyone had joined. If you say we can start, sir.
Let us start, Ashok.
Okay, sir. So, respected member services, Nizamul Haq sir, DG and Head of NTI, Shri UK Srivastava sir, DDG Training Adhir Singhal sir, DDG ICT Srinivas Changati sir, our eminent speakers, senior officers and distinguished participants. Good morning to everyone and very warm welcome to this webinar on 5G use cases in manufacturing and logistics sectors. I am Ashok Kumar, Director Wireless Access here. Myself and Vinay, who are part of Wireless Access Division, would be moderating this particular session. Agenda for today's webinar, we have inaugural session, which will be inaugurated by Shri Nizamul Haq, Member Services DCC DOT. Then we have first session on 5G use cases in manufacturing and logistics sectors, which Professor Brajesh Lal, IIT Delhi, would be taking. Along with him, we also have Professor Arjad, who would be taking the session. Professor Brajesh Lal was engaged in some other meeting, so in between he'll be there in the meeting, and Professor Arjad will be taking this session. The session 2 is about showcasing 5G use cases in manufacturing and logistics sectors for India. So we have representation from Nokia, Vodafone Idea, Jio, and Neural Networks. So we'll be introducing these speakers after the inaugural session. And then finally, we have a question answer session and vote of thanks. So let me brief all of you about the MS Team platform and certain housekeeping aspects of this webinar. So please use chat box in case you have to ask any question. Please use chat box to ask the questions during the session, which are being taken by respective speakers. At the end of the presentation, the speakers would be answering your queries in the chat box and also himself during the session. We also have question answer session at the end of all the sessions. That is session 3. So at that point of time, you can raise your hand and will allow you to open your video and audio and ask your question. During the session, we will be allowing only the chat box questions, right? So let us proceed further and request our DG Shri UK Srivastava sir for welcome address. Before I hand it over to sir, let me just give a brief introduction of sir. Sir do not need any introduction, but we have already 170 plus participants. For their benefit, sir is an ITS officer and presently heading NTI Pret as DG. And under his able leadership, NTI Pret is conducting various national and international level training and capacity building programs. These includes certification course on 5G network security, webinars or various emerging topic of national and international importance, training and capacity building programs for foreign delegates as part of ITEC and APT programs, induction and mid-term training for ITS officer. And of course, our mandate is policy research and innovation also. So under that head also, under such guidance, we are making good progress. So with this introduction, I hand it over to UK Srivastava sir. Sir, over to you.
Thank you very much, Ashok. Ladies and gentlemen, good morning to all of you. At the outset, I extend very warm welcome to Shri Nizamul Haq ji, Member Services, Digital Communication Commission, who has kindly agreed to inaugurate this webinar on 5G use cases in manufacturing and logistics sectors. Welcome, Haq sir, to this event. And we are conducting this webinar in collaboration with TSDSI. We have therefore a large number of dear members also joining today. I must inform you that we are also live on our YouTube channel. So simultaneously we are casting it on YouTube channel also. I welcome the eminent speakers who are joining today. They include Professor Rajesh Lal from IIT, his colleague Mr. Arjun, Professor Arjun, Mr. Rajiv Saluja from RGO, Mr. Amit Rao from VIL, Mr. S. Baburaj from CSA, Abhijit Chaudhary ji from Neural Network. Welcome all of you. And I also welcome the officers from DOT headquarters, field units, CDOT, TUC, TRAI, telecom industry, academia, etc. Not to miss my colleagues from NTI Pret. Most welcome all of you. Ladies and gentlemen, this competitiveness is everything to manufacturers, and much needed gains in efficiency and profitability will have to be achieved through new processes, innovations, etc. And these includes, for example, the continued automation of robots and warehouse transportation and cutting cables to become truly flexible. 5G and IoT will be key to enhancing and enabling these advances in manufacturing. 5G networks offer manufacturers and telecom operators the chance to build smart factories and truly take advantage of technologies such as automation, artificial intelligence, augmented reality for troubleshooting, and Internet of Things. With 5G, operators can create new revenue streams alongside energy and utility manufacturing represents one of the most significant sectors for new revenue potential for operators addressing industry digitalization with 5G technologies. According to one of the Ericsson studies, the 5G business potential, which is titled, the expected addressable market in 2026, that is 3 years hence, will be $113 billion US. So it's a huge forecast. you can understand how important manufacturing is, how important 5G is to manufacturing. Similarly, for 5G will also allow better logistics operations with more innovative inventory management and seamless fleet management. 5G connectivity promises more efficient supply chains, which means that it is going to be easier than before to track down an item from point A to point B, even if they are located across oceans. 5G connectivity will also allow for better parts tracking and inventory management, which should reduce out of stock items. It will make it easier to send urgent or time-sensitive freight with greater accuracy than ever before. 5G technology is expected to enable safety enhancements such as vehicle collision avoidance that may reduce accidents and related costs. 5G connectivity will also lead to lower fuel consumption, which is good for all of us. So as such, the 5G benefits all the sectors, and accordingly we conducted webinars on health and agriculture and then power sectors in recent past. This particular webinar, today's webinar, is in series of that webinars we are conducting for various sectors. I hope that this discussion today will be informative and educative to you all. So once again, thank you very much. Welcome again. Thank you.
Thank you, sir. Thank you, sir. Proceeding further, so we have with us Shri Nijamul Haq, Member Services, DCC DOT, for the inaugurating this particular webinar. So before I hand it over to sir, let me introduce. Sir is an ITS officer of 83 batch, and sir has worked in DOT and BSNL in various capacities in all field of telecommunications. And before joining as Member Services, DCC, sir was advisor operation, DG Telecom, DOT, and also advisor Delhi LSA. So sir, over to you for inaugural address and also declaring this webinar open. Over to you, sir.
Thank you. Dear Yukeshwar ji, DG NTI Predictive, ladies and gentlemen, good morning to you all. It is a great pleasure to be with you all on the occasion of this webinar on 5G use cases in manufacturing and logistics sectors being conducted by NTI Predictive. At the outset, I would like to congratulate NTI Predictive for organizing series of webinars on focusing each time on different verticals for 5G use cases. We all know that 5G technology will have a huge impact as a facilitator, catalyst, and driver for economy in each and every sector. Friends, the COVID pandemic taught us the importance of technology in our lives. The technology and progress made in the digital transformation have proven to be a great advantage during the pandemic. The fifth generation of mobile communication, 5G, presents new horizon for all the sectors of economy by enabling faster connectivity, speeds, ultra-low latency, and greater bandwidth. 5G will not just be limited to enhancing day-to-day experiences of mobile users, but it will be transforming industries as well. 5G promises to provide the foundation for flexible, efficient, and reasonable business. It can do so in many ways by making production lines autonomously reacting to supply and demand, enabling use of digital replicas that can warn about real machinery fault ahead of time, providing full traceability down to the individual item at warehouses and port, allowing remote access to powerful robots and vehicles for improved safety in risky environments. For India, 5G forms a key element in the making of Atmanirbhar Bharat and achieving the ambitious target of $2 trillion of annual exports by 2027. If you look at the logistics sector of our country, the logistics cost has remained around 13 to 14%, much higher than that compared to that of developed nations. This hurt the competitiveness of our exports. The government is aiming to trim India's elevated logistics cost by as much as 5% points over the next few years. 5G is a potent tool to achieve this. Therefore, today it is essential for all of us to be well aware about this revolution that is already here. And I am glad that NTI-PRIT has continued this series of webinars on the theme of 5G use cases of sectors of economy, as well as its clarification course on 5G. Today, in this webinar, we have expert speakers from industry, academia, and R&D who would be covering in details 5G use cases in manufacturing and logistics sectors. I am sure all the participants would get benefited by the different perspectives brought in by these eminent speakers. With these words, I declare the webinar open and convey my best wishes to all the speakers and the participants. Thank you all.
Thank you, sir. Thank you, sir. And now webinar is open for technical presentations. I hand it over to Vinay to further take the proceeding. So over to you, Vinay.
Thank you, Ashok sir. Member services DCC, DG NTI-PRIT, our other dignitaries, esteemed speakers, all the fellow NTI-PRIT officers, and our dear participants. I welcome you all to this webinar, and I am excited to introduce to you the eminent panel of speakers that we have for today's webinar. So first, we have the team from IIT and led by Professor Brijesh Lal. Professor Lal is the former head of Bharti School of Telecom Technology and Management. He is the coordinator of 2 centers of excellence at IIT, one of Airtel as well as that of Ericsson. And he is also in charge of IoT laboratory that was set up in collaboration with Samsung. Along with him, we have from IIT, Ashok sir, can we please change the slide, sir? Just a minute.
Go ahead, Vinay.
Ashok sir, please change the slide. Yes, sir. So along with him from IIT, we have Shri Arjad Alam Kherani. Sir is the associate professor in IIT Bhilai. Sir has worked on broad areas of computer networks, queuing systems, wireless communications. He also has worked for industry for a decade and more. And he is presently the adjunct faculty at Bharti School of Telecommunication, IIT Delhi. He is also co-founder of Agverse Technologies Private Limited, and he chairs the working group 2 SGSS of TSDSI. Next, we have speakers from industry. So we have Shri Rajiv Saluja ji with us. He is Vice President at RGO. He has extensive experience in working on path-breaking projects on emerging technologies like 5G, IoT, cloud, and artificial intelligence, along telecom as well as other sectors like transportation, smart city, etc. And he has been working in the areas of consulting, technology solutions and strategy, as well as consulting and service with service provider organizations. Next, we have next slide. Next, we have Shri Amit Rao, General Manager from Vodafone Idea Limited. He heads the team of new technology and architecture team at Voda Idea, and he has more than 21 years of experience in the telecom field. He started his career with Global Telesystems Limited and have worked with cellular mobile companies like BPL, Ericsson, and is currently working with Voda Idea for last 6 years. And next, sir. So next we have Shri Baburaj, he's CTO of Nokia Enterprise for GSI partners. He serves as strategic advisor and solution architect for GSI partners and their customers in India as well as globally. He helps them to prepare their information and communications technology infrastructure to meet their technical and business challenges of the future. He has experience in verticals like manufacturing, energy, and transportation, where he has worked to leverage Nokia's communication platform to derive drive them towards the industry 4.0. And next we have Shri Abhijit Chaudhary. He is the CEO of Neural Networks. He's also the founder of Neural Networks, and that is specially working on developing a cloud-native 5G edge networking platform for the enterprises. He has worked around 2 decades in the sector, telecommunications sector, and on data networking industry. He was part of the initial engineering team of Apigee that was acquired by Google and had previously worked with Sandvine, Cisco, and Motorola. Mr. Abhijit is active in startup ecosystem and contributes to events in 5G, open source, and software-defined networking. So now I hand over to Ashok sir to invite our first speaker for this session, the team from IIT.
I request Professor Brajesh Lal, in case sir had joined, and Professor Arjad Alam. Professor Arjad, if you want to, I'll just unshare and then you can perhaps share your screen.
Okay. Yes, thank you, Ashokji. And good morning to all, and good afternoon, good evening, depending on your time zone. I'll share my screen. Just give me a second. Okay, so I hope my screen is visible to all.
Yeah, it's
and
visible.
My audio is also clear.
Yes, it's clear.
Okay, so I have been requested by Professor Lal to kind of present this and or more discuss our understanding of 5G use cases in manufacturing and logistics sectors for India. It's a very good initiative from NTI-PRIT. So thanks to NTI-PRIT in helping us disseminate our knowledge and whatever we understand, and also interact with others from industry. Just to give you a brief background, and the main purpose of this slide of my experience so far is to bring out how in last 2 decades things have evolved. Most of us have worked on different aspects earlier, like in 2003, 2005, we were working on wireless sensor networks. Then there was vehicle-to-vehicle communication system in General Motors that I was working on. Then LTE system design, and then came IoT, 5G communications, and now we are working actively on smart ambulance, multi-access. So what I wanted to bring out from this is that many of us have, over the last 2 decades, worked on many small aspects, which are now all converging. And it is an exciting time to see that all the small efforts that we had put earlier are kind of coming together. In today's discussion, I will start with a small disclaimer that 5G applications and their enablers is a huge topic, and I don't think one person can do justice to that. Here, I'm going to basically attempt in putting together several such aspects in one place. We will not be able to cover anything in lot of detail. Hopefully, you will see a coherent treatment. If not, please stop me, depending on the protocol of the meeting. You can stop me and ask me to course correct. Also, other part is that because in the next session, we are going to have representatives from industry. I would limit my own delivery of this talk to that of a researcher or system designer level, more from an academicians, how they get excited about all these things, rather than the executional part. And I'll leave the executional part to the next session where we have very experienced speakers. So with that, I'll start a brief overview or recollection of, so most of us have seen this evolution. We had 2G in late 90s, and then we saw 3G, which was basically a transition to 4G. Then we saw 4G and its more acceptance in common as a common service available to all. Now, my own view is that 5G is just like 3G was a transition from 2G to 4G. 5G is in some sense a transition from 4G to 6G. The reason I say that is that 5G is basically has broken from the traditional monolithic model of 2G was completely voice, 3G was voice plus broadband something, 4G was more data rate, mobile broadband. 5G is the first one where you can have different technologies serving to different applications. So 5G is the first technology where we see people talking about different verticals, and they have different requirements, right? So 5G supports a wide range of applications, different technical solutions for different applications. Some may be called 5G in some domains, some and the same technology may not be qualified to be called a 5G in another domain, right? Application. So we are essentially seeing a transition towards a richer collection of edge services and devices. And as I said, we may not see the full potential of all this movement right now. But over time, as we see, if we view 5G as a transition step from 4G to 6G, within the next 6-7 years, we are going to see lots of such things coming up and affecting our daily lives. And I will try not to be giving any visionary statements here, but that's what I hear from most of the colleagues. So this is a slide which is, I think, many of us already know that 5G has these 3 different verticals. Each vertical is basically catering to different applications. Those who are involved with 5G standardization know also that this were not the 3 verticals. These were not the only 3 verticals that they started with. Lots of deliberation goes into this kind of description of 5G, 6G, 4G technologies. So several were kind of killed in between. Eventually, what was left was MMTC, URLLC, and EMBB. So EMBB is basically an extension of what we have seen in 4G, enhanced mobile broadband. Then we started getting this ultra reliable, low latency communication to support mission critical. People have to think about why there should be extreme mobility support in URLLC. So that I leave for the audience who are not aware of this thing. As I said, I will not get into lots of detail. And we are now talking about massive machine type communication. So many devices which are kind of talking and exchanging information. These are supposed to be relatively dumb devices and so on. So I hope many of us are familiar with this kind of these 3 verticals overall. This is the famous 5G triangle where we see EMBB, URLLC, and MMTC, each of them having their own target objectives. All of them qualify to be URLs to be 5G within their domain, but they may not be able to qualify as 5G in the other requirement. For example, technology which is doing URLC, which has ultra low latency, need not give us extreme data rate, right? So that's kind of understood. A generic 5G architecture, we don't need to get into this, but the idea is that many things are happening here. So all the technology that we have seen in last 2 to 3 decades, which had many proprietary solutions also. For example, if we look at very special case solutions also, which people came up with in the the first decade of this century. They have started becoming more formalized. They were more accepted in standards. So there were lots of ad hoc solutions earlier, even in wireless sensor networks and all. Now they are all getting standardized. So those efforts were not wasted. They have now found their way into standards, and now they are getting into the field. That's what this slide would suggest if I have to summarize it. So we know that many technologies like massive MIMO, small cells, cognitive radio, NFV, they were all, lots of these things were independently studied and developed. And in very specific domains, and there were lots of proprietary nature to all the solutions which were there earlier. There were many versions of NFE, there were many versions of D2D, and so on. Now they have all converged. So the people who are involved in standardization have done a very good job of kind of uniformizing and harmonizing all this various technologies which are available, and this activity has not stopped. It is still going on, this kind of harmonization and looking at what technologies are available, and people are still now we have started talking about 6G standardization and scoping out. So first is scoping out and then standardization. So many enabling technologies are there to fit the different. So important point is that we are looking at different 5G wireless scenarios. And on the core network side, so we had many good contributions on the WAN side as well as on the core network side. Even though the skill set required for this are different, they have all come together. You have on-demand slicing and all now, and we'll see in some time how this on-demand slicing can help get a scalable network architecture in industrial applications as well. So 5G and beyond is basically, if we summarize, it is about connectivity, control, and compute all coming together and kind of complementing and supplementing each other. So now coming to the main topic. Sorry, Vinay, you can please let me know when I have to stop. Just, give me 2 minutes time before I have to stop, and I try to be within my 10 minutes.
Sure.
So 5G in logistics and manufacturing, one of the key elements that we are now looking at is we have now started talking about smart manufacturing, which has very kind of always on process automation, remote monitoring, and maintenance. And one of the key points is that we are now trying to come out of the wired connectivity part. It's in some cases wired connectivity cannot be completely done away with. There are practical restrictions. For example, if you are having a sensor inside a cold storage unit, then you certainly have not much option there. So that's kind of a radio shield box in some sense. So there's a few cases where you will be able to not replace wired connectivity, but in other places, yes, you will be able to. So sophisticated control systems along with AI vision, camera, and autonomous robots and all. So those are already becoming practical. I remember that in my last startup, we were having this very rudimentary version of motion detection cameras, and that was like almost a decade back. Now things are much more advanced. Right? And all of this is happening in a basically roughly 400 megahertz processor. So that those were happening inside the camera, IP camera online, but now a lot of such AI is also getting shifted to the edge. And we are actively working on edge as part of our activity in 5G testbed with IIT Delhi. So that's about that. What we see is that again, I mean, there's a lot of text here. Apologies for that. So I kept a lot of text here because I assume that we will be sharing the slides after this, and many of the participants are this being an informative, a tutorial kind of session. They can possibly look at this text later on. So I don't have to go through this all the text here. So one of the key things from my point of view is effectively looking at the maintenance and lifecycle management. Remote management is certainly already there. We have seen lots of remote management solutions earlier, as I said. Then we are talking about automated guided vehicles, which are, again, they will have very the time criticality of those applications are significant. So we need to also cater to them, and that is where URLLC and URLLC comes in. Some range is also required. You can see that Wi-Fi is getting replaced gradually. So we are also seeing the Wi-Fi, a kind of competitor for campus-wide network, which is like private 5G networks and all are coming up, which may be, at least from a campus perspective, for campus like ours, it's it's challenging to cover all the area with Wi-Fi. So people are talking about 5G private networks where whole campus can be covered. So, and these are certainly very important in manufacturing also. And the 3D parts in additive manufacturing is also coming up. I am not an expert in that, so I don't know too much about that. What I understand is that it will certainly get help. So I'm coming at it from the point of view of a 5G technology developer, 4G 5G technology developer. There are lots of applications. So we think that 5G will certainly boost the process of 3D additive manufacturing, parts in additive manufacturing. Real-time video analytics I have already talked about, and we think that 5G is going to be an enabler, and it will support many connected devices along with edge computing. So the idea is that edge will be able to filter out or reduce the load on the backbone or the core of the network. So that's where the huge number of connected devices can be supported, and this certainly has a significant improvement in or potential for manufacturing. One should be able to combine and control the data coming from wireless data coming from the different robots. If you have a scaled version of robotic system, and if you are able to trying to control lots of such robots on an industrial floor, then the requirement from 5G. The requirement put on 5G technology is huge, and we think that that can also be handled. And again, coming to the human interface, we think that augmented reality and all will help better visual interaction, which will kind of speed up the safety considerations. Okay, so with that kind of intro. I'll now talk about two things. First is that the technologies that come in, which enable the manufacturing and logistics, and then some of those applications in manufacturing and logistics. So I'll try to go through these slides very quickly. So first is obviously Industry 4.0. We have heard a lot about Industry 4.0 or 4.0, as people say. So certainly one of the key areas there is smart manufacturing, smart warehouse, and digital twins. So many of us are aware of digital twins and the communication requirements for those. As 5G develops, we think that it will offer many new capabilities. And again, I am repeating this, but from my point of view, 5G is a transition to 6G, which will possibly be a more stable and more adopted kind of technology, and that is where we will see lots of use cases of this. So some of the key areas where we think that 5G can create substantial change in supply chain are spot on the location tracking part, virtual mechanic, and predictive maintenance. This is kind of when we say virtual mechanic, we kind of start getting into the digital twin domain. So computation is certainly required there, but the communication part is also huge, and the convergence of computation and communication is what we see here in virtual mechanics, and the required digital twin requirements. Asset performance management and tracking is something that we kind of keep on doing. The second is the sensor technology itself. So I'll not get, this is not directly related to 5G, so I'll not get into this too much, but we understand that a good sensor the sensor technology itself is evolving, and it is becoming more and more mature and more optimized, which is helping in manufacturing already. Now, how this affects our 5G part is that the more sensors would require, and in a couple of slides, I'll talk about reconfigurable intelligent surfaces, which talk about how the sensors need to be integrated with the communication system. So better sensors, compact sensors, and cheaper sensors, but their cost may start getting dominated by the wireless technology that they are using for communicating their sensor data or their own data. So that's where we think that 5G also will help, and I'll come to that. We are essentially looking at wireless IoT sensors, which will become more and more, which are more and more reliable, and that way you'll be able to kind of attach lots and lots of sensors. People are already doing it, so the executioners who are going to talk about this aspects in the next session, they already know and they are already aware of many such deployments. So I'm just telling how this is coming in. So IoT sensor, if we say IoT sensor requires wireless communication to be more pervasive or to scale. If we are talking about wired sensors, then the scale may be limited. I'm not making a strong statement that it will always be limited, but it may be limited. Right? So to scale, wireless will be required, or wireless will help in scaling the number of sensors. And obviously sensors have their own advantages. Another point which is going to be important and which is a technology enabler is slicing. Now, slicing, if you are familiar with it, basically all it does is that it kind of makes multiple logical networks within the network, right? So it's like, in some sense, we can say that it is like running a virtual machine inside you on any system. It's not exact, I know, it's very inaccurate, but for new for beginners, this may be fine. Slicing can be done at RAN, radio access network, or core, or transport, or edge, anywhere essentially. So it's basically a software construct where you can kind of logically segregate different requirements and into different layers, and they have their own management layer. Network virtualization is a next technology which is basically helping the infrastructure providers to decouple their applications and services. So that's where the network virtualization helps. These are the technologies. Network slicing will help. As device count increases, you will see more and more the network slicing automation itself being more important. So slicing is one thing that you can achieve, and then as the system scales, you will have requirements on slicing optimization itself or management. So like what we saw, SO and so on concepts earlier, optimizing networks or self-organizing networks. In similar way, we'll have to have some automation on how to manage slices, and so obviously standardization is going on. And that, IIT Delhi is also very actively involved with this kind of standardization. Professor S.K. Gupta's group is involved. So what we see is that in one of the key challenges that I see personally, I mean, there are many other obviously, that I see is the limited RAN resources. So I come more from the RAN background. So I see that one of the key issues in network slicing will be limited RAN resources. But when we are talking about manufacturing, where we may have less mobility. So if one looks at the challenges that the RAN faces in managing or scheduling different users, a lot of those complexity is basically around mobility. So if the user's channel quality is going bad, improving, you have to continuously track and all those things and do adaptation. But maybe in an industry setup, not in a robotics kind of widely mobile setup, or we can say that in industry setup, there's some amount of predictability also. So either it is deterministic or some predictability is there, which can lead to better algorithms, and the limited RAN resources will then have to be better utilized for managing the different network slices, if that makes sense. Now, this is a technology enabler that we are actively working on currently. And
yes, sir, I just request that can quickly finish up because of when we have many sessions, no?
Yes. So how much time do I have left?
I mean, how much time do you need to?
The slide deck is huge. So whenever you ask me, I'll stop.
I thought that we'll be covering in half an hour, so total half an hour. So maybe you can take 5-6 minutes more, sir.
Sure, sure. Please let me know when I have to stop, and I'll stop. I know that I'll not be able to complete the slides that was given to me. Sure.
Right.
Okay.
So key slides, you can take it up next 6 minutes.
Yes.
Your slides, please, sir. And maybe we can share the slides so that we share it with the audience who have joined, so we can go through the slides later on.
Certainly. Yes. So what I'll do is I'll just briefly describe about this reconfigurable intelligent surfaces, and then I will stop. And the other parts are already in the slide. So one of the things that we are currently working on is something called reconfigurable intelligent surfaces, where we see that it will have huge impact in the industrial IoT applications, because we are talking about lots and lots of sensor nodes, right, and multiple wireless technologies which are working in parallel. So what happens traditionally is that each and every sender and receiver is running its own complex channel estimation algorithm and so on. So that leads to a lot of intelligence at the sender and receiver to be able to reliably and better exchange data. So usually what happens is that sensor manufacturers are kind of forced to work with and choose the right wireless technology, which leads to some kind of interoperability of issues. It can be difficult for smaller wireless technology providers getting into that, and this also increases the end device cost significantly. So the idea is, if we are able to control the channel and leave the end devices dumb, so that way basically there's not much of a signal processing which is happening at the sensor nodes, that will bring down the cost of the wireless part of the sensor node. And once the solution is using or enabling a smart radio environment, which can be done using reconfigurable intelligent surfaces. So the idea behind reconfigurable intelligent surfaces is relatively very simple. If you have a grounded metal layer, so as you see here, there is a grounded metal layer here. So if an electromagnetic wave impinges on this layer, then ideally it should get reflected, Snell's law will be followed and so on. But if we can apply a substrate and do some small trick by using by changing the surface impedance of this particular structure, then we will be able to kind of direct, so do a in some sense do a beamforming or do a channel equalization separately, okay, without talking to the end devices. So this is a very interesting field which is coming up. We are also actively working on this and standardization of this. We think that this will be very useful in the factory floors and in manufacturing systems. So if I have 2 or 3 minutes left, then instead of talking about all the key application areas, I will just talk about the haptics part here. So we had 3 or 4 areas. So I'll just go to haptics and then stop. Would that be fine, sir?
Yes, please. Yes, please.
Okay. Okay, so we are currently also actively working on haptics and tactile internet. So TI stands for tactile internet here. We have seen that so the requirements for tactile internet is essentially of this kind. So the tactile internet requires the underlying communication system to provide an end-to-end latency of 1 millisecond, a very high reliability, security, and as well as scalability at all the protocol layers. Now again, some of the numbers, so except for this latency 1 millisecond requirement, some numbers, not everything is directly quantifiable, but the idea is that this is much more responsive and much more real time than what other applications may require, right? So what we are doing right now is that we are having this kind of mobile edge computing solution, where we think that tactile internet will help from the intelligence available at the edge for such systems, where the edge can possibly, for example, take over when something is about to go wrong or things like that. Okay? So overall, in terms of architecture, in industry floor, we are talking about the master domain where you have the actuators or the sensors in some sense or the controllers. Then you have the communication infrastructure, which is the bidirectional haptic control. And then you have the actuators, the ones which are actually getting used. Right? So the control domain, so to say. So this is a standard terminology: master domain, network domain, and control domain. We think that this is going to be very useful in the manufacturing sector going forward. And even though 5G currently does not completely support it, we are getting there. There are lots of challenges. We are actively working on edge computing aspect, which are related to the tactile internet part. So with this, I think this is a logical point to stop. Thanks for hearing me out and giving me time to share.
Thank you so much, Professor Arjun. It was a wonderful presentation. You shown us a lot of aspects of 5G and also particularly in manufacturing and logistics sector. So I would request our participants that if you have any question, please use the chat box, or there is a question answer tab on top of the Teams app. You can also use that. And Professor Arjun, there are already 2 questions in the chat box. What I request that if you can answer those 2 questions in the chat box itself, it will save time, and also I can invite the next speaker in between. So whatever questions are coming, may I request Professor Arjun, I mean, you're okay with answering in the chat itself?
Sure. I understand that will save time. So we'll do that in parallel. I'll be answering the chat box. Thank you, sir.
Thank you so much, sir. So participants, do ask your question. If you have any question from Professor Arjun, 2 questions are already there. One by Mr. Sanjay Kumar Gupta and other by Mr. Ram Prasad. So Professor would be answering those questions. So may I now invite Professor, S. Baburaj, who is CTO CSA of Nokia Enterprise for the GSI partners. So welcome, Mr. Baburaj. Can you open your mic and video?
Yes, thank you. Thank you, Ashok, sir. Are you able to hear me well?
For joining, and welcome again to this webinar. Maybe you can share your screen, sir.
Sure. I'm sharing my screen. Are you able to see my screen?
Yes, we can see. Very nice, okay. Very colorful, vibrant screen we can see. Please go ahead.
Thank you, sir. Yeah, thank you for giving this opportunity for us, for taking this through. So what I will do is I will take forward from what Professor mentioned now. So Professor nicely showed us how a 5G network is designed and what is the overall architecture and what are the possible use cases that it can open up, right? So I'm just moving on from there. So the first one is that there are a lot of challenges that enterprises in manufacturing and logistics have today, right? And these challenges have led to new type of innovations and requirements, right? So I'm taking discrete manufacturing as an example, but it will be similar for a process manufacturing or an auto manufacturing or any other kind of manufacturing also, right? So this is an example that I have taken. So if you look at it, you can see that the kind of give me a minute. I have some issue with my. I will share it again.
So you can share the full screen so that it will move.
Yeah, that's what I'm trying to say. Yeah, now it is fine, right?
Yeah, it's coming.
नहीं ये डॉक्यूमेंट बना के और वो सेल वाला डॉक्यूमेंट फाइनल दे दे.
Yeah, so continuing, so the different kind of challenges, right? So each and every manufacturer want to improve their efficiency and productivity. They want to be much more flexible and agile in their way of working. And today, as Professor also mentioned about competitiveness, and that fast decision making is very, very important, right? How to make sure that the factory has the maximum uptime that it has possible, the manufacturing process itself. How can you have real-time interaction with the partner ecosystem and the other ecosystems that they have around? And how to make sure that the research and engineering quality is of very high quality to make sure that you are doing right the first time itself. So those are the kind of challenges that manufacturing and logistics are facing today. And this has led to different kind of innovation and requirements, right? It has led to increased factory and shop floor automation. It has made much more data collection to get much more data insights, right? It has led to real-time planning and changeability, how to do real-time planning and changeability, right? How to make sure that the worker augmentation is done and remote support is as good as possible. So in the last 2 years, we know that remote support has become one of the most important aspect in each and every area of enterprise, more so in manufacturing and logistics, right? And how to have a reliable connectivity, interoperability and data exchange to make sure that all the use cases can run without any issue. How can I have a very, very reliable connectivity to make sure that my production is as flexible, is as reliable, and it has all the kind of competitiveness in the world, right? So that is where the requirements has gone into. And these requirements about reliable connectivity lead to this, right? There are different kind of connectivity that is available. So from a wireless connectivity point of view, you already have Wi-Fi, which is very, very prevalent everywhere, right? Then you have 4G LTE, and then you have 5G, right? These are the prevalent new technologies out there for providing you flexibility of connectivity, right? So what happens is that all these things help enterprises in different ways, right? So Wi-Fi can be used for what we call a business-driven communication, right? All the day-to-day business, all the IT connectivity, all the office communication, and all this kind of stuff can easily be done using a Wi-Fi, right? So you can see here what is the kind of capacity it has, what is the kind of coverage each of the access point has, what is the kind of quality of service. So it's a best effort, lack of prioritization is there in Wi-Fi, but it is enough for business-driven kind of an applications. Performance, it has high peak rates. It can get into very, very high peak rates, but it is not very reliable. It goes high 1 second, it goes low into the next second, right? And from a mobility point of view, if you have mobility, means if you have AGVs, if you have different kind of vehicles that are moving around your shop floor, and you want very, very reliable connectivity for them, Wi-Fi may not be the right solution. And security also, in plain vanilla form, Wi-Fi has certain amount of security, but it is not inherently secure like what we have for 3GPP technologies like 4G and 5G, right? And same thing when you're coming to 4G and 5G, this is mainly used for operational technologies, right? For all the operations of manufacturing and logistics, right? So it will give you a reliable, very secure connectivity to make sure that all your business critical and industrial grade communications can be done. So you can see the kind of capacity improvement that happens, the coverage improvement that is there. So LTE and 5G are so flexible, right? It can have a coverage from 50 meters to even kilometers, right? Depending on the kind of radios that you use, you can have large coverages also. QoS, that is one of the biggest differences. There is prioritization. There is a managed QoS in 4G. And as we discussed in the earlier session, network slicing also comes into 5G, right? So it is managed, it is prioritized, and you can slice. You can have different slices for different kind of applications. So you can have one slice that is only for your video cameras, for your surveillance, right? One slice only for your machine PLC data, right? Only one slice for only your sensor data, for example. So you can have separate logically different networks to make sure that you have enough of your throughput, enough of your latency, and all the things are defined for each of these slices. You can do that with 5G, right? And it is much more predictable. That is one thing. It's the reliability of LTE and 4G and 5G are unparalleled for a wireless network, right? You can get 3 to 4 nines, that is 99.99 kind of a predictability and reliability in 4G, and for 5G you can go up to 5 nines, 99.999 percentage of reliability, right? And mobility, we know how mobile we can use 4G and 5G with mobile. When you are mobile, sorry. So when you're on a car and you are using your mobile phone, you don't have a connection break, right? That itself is a example of 4G with mobility. And again, latency is very, very stable. So you can see Wi-Fi, the latency, you can get even 1 millisecond latency, but it fluctuates. It fluctuates between 1 millisecond to 2 seconds even. But when you come to 4G and 5G, the most important thing for automation is stability, right? And that stability is there for 4G and 5G, right? And again, security, you know that 4G and 5G are inherently secure. The first and foremost security is that you need a SIM to access a 4G or a 5G network. That is the first and foremost inherent. And even the air interface is encrypted in case of 4G and 5G. So those are the kind of differences between Wi-Fi, 4G and 5G. And please note that all these networks have their roles to play. They will coexist, right? And they will collaborate with each other to make sure that you have a seamless experience everywhere. So your IT can be easily managed by Wi-Fi. Your OT can be managed by 4G today if you have 4G. And when 5G comes in, you can have all your kind of use cases, most of 99% of your use cases covered, right? So that's how it is positioned from a wireless technology point of view. And going towards use cases, right? That is today's topic. So when you have such a kind of reliable network coming in, when you have your 4G or 5G wireless network that is coming in, what are the different kind of use cases that will open up for a manufacturing, right? So if you look at it, the first one is what we call a digital factory campus, right? You can have a digitalized factory campus to make sure that you have the facility management, the sensors, for security and surveillance, the digital factory twin and drones for surveillance. All these things can be enabled when 5G comes in, right? So digital factory twin, as you know, is a digital replica of your whole factory to make sure that you can first test all your assumptions. You can see what's happening in your actual shop floor, and then go physically and do any changes if you want to, right? So that is where a digital factory campus and the use cases will come into foray when 5G comes into picture. And then when you go a little more further, automated shop floor, how to have much more automation than today, right? So we know M2M communication, it has been there from long, but this will evolve. M2M communication will now evolve to, for example, collaborative robots, right? The robots can collaborate each other wirelessly. How can you have quality management using video cameras? You can have visual inspection, wireless visual inspection, and do a quality management. That is what 5G will enable for you, right? You can have cloud robotics, you can have machine sensing and control, and process and product monitoring. How can you monitor the process and product wirelessly and automatically? So this is what automated shop floor kind of use cases will enable. Worker, so we discussed about augmented worker, right? So how can you have the worker much more intelligent than today? You can augment them with wearables. You can make sure that remote export support is there with different kind of goggles. So today you have RealWear kind of a goggle that can give you awesome experience for remote support. And 5G will enhance this further to make sure that you can have real-time video calls for remote support, remote export and support, and voice and video communication. You can have much more reliable voice and video communications in the shop floor using a push to talk or a push to video when you have 5G coming in. So you don't have to rely on your wired phones or on your narrowband old land mobile radio kind of phones, right? You can have much better wireless human machine interface, which is mostly wired today. So you can make it wireless. And you can also improve training and remote support through virtual reality. You can understand worker positioning much more easier when 5G positioning comes into picture, right? And you can also improve the safety. So those are the use cases connected work head brings into picture. and how can you make the assets more smarter, right? So you made people more.
Baburaj, we lost your voice. Please confirm if others are able to hear him. Anyone in the chat box?
No, we can't hear him.
Yes, sir, you are.
Can you call him, Vinay? Just call Baburaj that we have lost him. He
Yes,
should reconnect. Please hold on for a moment. We are calling Mr. Baburaj. I think we have lost him. Right. Please hold on for a moment. We are connecting Baburaj. Yeah.
Yes, sir. He is reconnecting, sir. Just a minute.
Okay.
Hello,
Yeah,
are you able
yes,
to
yes, we can see, we can hear you.
So
Yeah,
where
just
did I
share
where did you miss me? I don't know. I was on my slides.
So immediately you got disconnected. So wherever you are currently on your side, same slide you
Okay.
can continue.
Okay, great. I will do
Yeah,
that. Yeah.
this slide, and then you can click few more times.
Yeah.
Yeah.
So
You were on the connected worker.
So you had already covered connected worker. So perhaps you can move to a smart asset.
Sure. Yeah. Okay. Thank you. Yeah. So then coming to the smart asset, right? So I was going on speaking. So what I was saying is that we have made the worker smart, we have made the shop floor smart, and we have made the digital campus also smart. So what we are looking at is how can we make the asset more smarter, right? So you can have how to make assets smarter. So you can have condition monitoring of assets to make sure that you're monitoring the conditions, and then you do predictive maintenance of these assets much more easier than today, right? To make sure that your maintenance costs and maintenance time is reduced as much as possible. Another one is asset positioning, which is very important for warehouses and for manufacturing. To make sure that you have sub-meter kind of, even centimeters kind of positioning that is needed for positioning your assets. And this will be enabled when 5G positioning comes into picture. So that is getting standardized, and it will get also into the mainstream soon enough. So that is also one more thing that will get enabled, right? Another one is to have remote configuration control, remote maintenance, and automated guided vehicle. So even Professor talked about automated guided vehicle. So I'm not going extensively into it. So that also you need a very reliable and connectivity that allows mobility. That is where you can make assets smarter. So these are the different heads and different use cases that will get enabled when 5G comes into manufacturing, right? And how is it getting enabled? It is getting enabled by having a very reliable network. So you will have the wireless network to connect most of them. Then you will have some fixed network that is there, which is already there, right? And then if there are multi-site connect, you also need multi-site connect, right? So you have multiple factories to be connected, you have multi-site connect. And then sometimes you may also require a seamless kind of a global connectivity, and IoT connectivity across the world. So these are the different connectivities that manufacturing may need. And these are the use cases on the shop floor and on the factory that can get enabled, right? So just touching up on this, I will not take much time here. So this is how it will ultimately come into picture, right? So on the left, you have different kind of devices that manufacturing has. It can be an AR, VR equipment, it can be a sensor, it can be a PLC, it can be an industrial machine, it can be camera. All these things has to be wirelessly connected to the business applications that manufacturing has, right? So this is the access that will come in. So you will have the 5G network that is coming in with 5G radios, indoor or outdoor, right? So indoor, you will have the what we call a pico small radio, and in outdoor, you may have a micro radio or larger radios as required, right? And it will come to the baseband unit. And then you will have an on-premise edge core, what we call. So Professor again talked about mobile edge computing, right? So this is the real mobile edge computing in play, where we have the core, 5G core, and also any kind of business applications that are required for manufacturing on the same hardware or the same cloud, right, on premise. And then it can also connect to the customer IP network, I mean the factory IP network, and the business applications that it has, right? So this is the high level infrastructure that will come in when 5G will get implemented in a factory floor, right? So similarly, right, I have 2 or more slides and I will stop. So similarly for supply chain, right? What are the kind of use cases and what are the kind of challenges that they have, and what are the use cases that will get enabled when 5G comes in, right? So for the supply chain, you have different kind of points where use cases will get enabled, and different kind of challenges in each of the areas, right? So you may have, for example, a supplier or a factory warehouse, then that will get transferred, right? It will get transported using a rail or a ship or a cargo, and it will come to the factory. And factory can have their own factory warehouse, and from the factory warehouse, something will be made and it will again be sent via different kind of modes to a fulfillment center, where you have a larger warehouse for all the kind of end goods. And from the fulfillment center, it will come to the B2B or B2C customer, right? Through different kind of modes. So this is the flow of the materials, the logistical flow that will happen, right? And you will need 5G for use cases, or 5G will enable use cases at each of these areas, right? So you may have digitization and automation in campuses, like campuses in these warehouses, in different kind of warehouses. And you may also need to have a kind of global asset management for having positioning, right? You may need to have outdoor GPS cellular positioning and also tracking of these assets, right? So that is what will happen. So will give you an idea. This is a little bit busy slide. Sorry for that. So these are the different kind of use cases that will get enabled in the warehouses or in the hubs, right? So if you look at it, the use cases, it is self-explanatory. So one is basically reliable wireless connectivity for automated vehicles. So inside warehouses, you will have different kind of automated vehicles, starting with such robots, with or going to larger forklifts and other kind of stuffs also. So you need a reliable wireless connectivity for them. So you will get that, right? Next is for manned operations. You need connectivity for the people, for example, for doing barcode scanning, right? You may need wireless barcode scanning that is required, and you need reliable connectivity across the warehouse where you have so much of stacks of pellets or whatever that is there, and you need reliable connectivity. So that's another one, to have wireless data connectivity for manned operations, right? Another one is for facility management, similarly for factories. Next is for positioning. We discussed positioning again. Next is wireless video backhaul. So there may be places where you cannot connect cameras using a wire, so you may need to have it wirelessly. So, and today the cameras are becoming more intelligent, and it needs much more detailed vision coming in. You may need 4K videos or 8K videos coming in, and such a video needs higher throughput, and that's where 5G will play a role, right? Then you will require voice communications. We discussed voice communication in the slide earlier. You may require gate automation, right? So you may have to have gate automation to make sure that your hub itself is automated, to make sure that the trucks come in as and when required, and the trucks go out as and when it is finished, and the people are there at the loading, unloading bay as and when required. So there are no wastages happening for resources or time that is wasted, right? Then you will have use cases like predictive maintenance. You will have worker safety. You'll have wireless connectivity for drones, indoor drones, right? So you'll need indoor drones in the warehouse for surveying and also for collecting. So the use cases are multifold for indoor drones in cases of in case of warehouses, right? And then you have hub activity. Different hubs will is another use case. So these are the different kind AR/VR. So AR/VR also for training and picking. That is also one more use case that will get enabled when 5G comes in, right? So you can see that many of the use cases with enabled with private wireless, that means private 5G. Some of them are for backhaul. So for example, multi-hub connectivity or LAN solution. Those are backhaul. And there are also analytic use cases like video analytics that is coming in. And video analytics can also may require high quality, high resolution videos, which again 5G will enable, right? So these are the different kind of use cases that will get enabled. Some of them are already there, and some of them are suboptimally there. So when 5G actually comes into picture, all these use cases will become reality in the true sense. Yeah. So this is from Nokia point of view, what is there from a supply chain digitization point of view, right? So Nokia has from a device point of view, we have ruggedized handhelds and tablets which can help in barcode scanning and other kind of stuff also. We have our 5G modems and dongles, which can connect to the legacy devices and make them 5G enabled, right? Yeah, our partner ecosystem have sensors, AR/VR devices, indoor drones and other kind of stuff. Nokia has its own industrial outdoor drones. So we have outdoor drones ourselves. And then 5G and LTE, I already showed you what are the different kind of 5G network elements that will come in when 5G comes in, right? So we have 5G in whatever flavor you want, right? We have SD-WAN, IP, MPLS, DWDM, CWDM also. We have a worldwide IoT network grid called WING, Worldwide IoT Network Grid, WING, WING. So it gives you asset tracking all over the world if you want to. For example, if you have a connected car, you want to connect it anywhere in the world, that is possible. Then you have our own data infrastructure, right? And then it connects to all these different kind of use cases, right? It has to connect to the WMS, the World Warehouse Management System, the automated fleet management, group communications is push to talk and push to video kind of use cases. You need high accuracy indoor positioning. Nokia has a solution here already using Bluetooth low energy. Then we have scene analytics, which is our video analytics solution. We have outdoor drone remote control. As we mentioned, we already have a drone. So we have an outdoor drone remote control also. And from our partners, we have inventory scanning, supply chain visualization, and partner applications also, some other partner applications also. And some other horizontal use cases like cybersecurity, network management, and network services. These are also part of our offering. So we almost give an end-to-end offering for warehouses, similarly for manufacturing also, right? So that is what we have from a use case point of view. This is my last slide. From a Nokia industrial grade private wireless point of view, normally enterprises require an solution approach, right? Not a bottom-up approach, but rather than a complete overall solution approach. And it has to have different kind of go-to-market options. It has to have different capabilities and coverage richness also. And that's where Nokia comes into play. We have a end-to-end capability, right? To make sure that we are not only talking about radio and core. We are talking about use cases. We are talking about solutions that manufacturing and logistics want, right? We have different kind of solutions that is easy to deploy and can be bespoke also, can be integrated as and when required. We have vertical segment practice inside Nokia. For example, we have the expertise of manufacturing and logistics inside to make sure that we are creating solutions that actually make sense for manufacturing and logistics. And from a partnership point of view, we have various and varied kind of partnerships, starting with CSPs, cloud, industrial, and SI and consulting partners. And from a global reach point of view, we already have 450 industrial grade private wireless already, 450 plus actually, nearing 500 now. And we are very, very laser focused on industrial automation. So Nokia has a very potent workforce are in enterprise, and we are laser focused on industrial automation. Yeah, so that is what I have today. Thank you for this again. Thank you for the opportunity. And any questions I'm ready to take, or I will also look at the questions and answer it over the chat box. Thank you so much.
Thank you, Shri S. Baburaj ji. We already have one question in the chat box. I request if you can answer that. The question reads like, how many RRH can be parented to BBU in an industry-based use case? And there are some other part of this question. So I request if you can answer in the chat box itself. In the meantime, I will take the next speaker on board. May I request you to kindly unshare your slide?
Yeah,
Baburaj,
sure,
yeah.
sure.
Yeah, so although the next session we had from Vodafone Idea, but our esteemed speaker from Jio, who has a very hard stop at 1, so he requested to take up his session. So may I invite Mr. Rajiv Saluja ji, who is Vice President RGO, for the presentation. So over to you, Rajiv ji.
Thank you so much, sir. Thank you so much for accommodating the request as well. Sincerely appreciate it. I will just present my desktop and let me know when you can see the screen. Is the screen?
We can see, yes, we can see your screen.
Okay, so first of all, thank you so much for the time, and the speakers before me covered the technology aspects and the use cases also in detail. So the 15-20 minutes I will spend more on how we can adopt this in India and what is required to bring it in India, with some special focus on connecting it with the projects that Government of India has launched in India to drive our digitization program, and how 5G can accelerate that beyond what we have seen so far. So as most of you are aware, that we are pretty late when it comes to 5G introduction in the country. There are more than 100 countries who already have deployed 5G. So it gives us an opportunity which is very significant, because we can learn from what others have not done right, and more importantly, we can see what is relevant for us and adopt and deploy what is relevant in the Indian context. So I will try to more spend time on the slides which connect us on that story than the general concepts. So the first this slide, I think it's already covered. We already know now the capabilities of 5G. So I will basically go on this slide. So when it comes to private 5G deployment, there are 3 possible scenarios. So scenario A is where this factory or this private enterprise uses the complete network from a telecom operator. And both the RAN as well as the user plane and the control plane are provided by a public network with some QoS, which the factory can utilize. The second type is where the radio network and control plane elements are shared with public, but the private network has its own local services on the local edge cloud. The third deployment that we are seeing is that everything, right from RAN to the control plane to the edge computing, is captive to the enterprise or the industry. The speakers before me spoke a lot on the 5G capabilities like network slicing, etc. So what we want to show you here in this slide, what we are showing is there are 2 possible deployments of 5G. One is on the non-standalone and the second is the standalone. Now, to deliver the true 5G capabilities, or the capabilities which the speakers before me highlighted, like the use cases for manufacturing, for dedicated QoS, network slicing, etc., can only be enabled in a standalone architecture. A non-standalone architecture, which basically depends on 4G network to deliver services to the 5G customers, was launched more for an early adoption of 5G when the standards were still being finalized for a standalone architecture. Now, globally, most of the operators have already started shifting towards the standalone architecture. There are deployments going on in about 38 countries now on standalone architecture. So it's a huge opportunity for us to go directly on standalone architecture and learn from the mistakes which others did, and the true potential of 5G could not be realized in those countries. Now, as Geo, we have developed our own product suite, both from radio as well as core, and it is completely cloud native. And we have already tested functionalities like network slicing, etc. And these functionalities are not possible in a non-standalone architecture. So this was one important aspect which I wanted to touch upon. The second is what is happening globally. So if I talk about private 5G, there have been multiple deployments. I'm just highlighting two here. These are the more relevant because the automobile sector in Germany has been leaders in adopting this robotics and 5G technology. So the use cases that they have deployed so far are basically related to automated quality control and robotics and also the assisted manufacturing, which the speakers before me spoke about. Now, the use cases in manufacturing, which we think will pick up in India, the first one we believe would be around the process automation. Here, basically, the repetitive and labor-intensive tasks will be automated, and these are already automated to some extent using wired robotics. But we believe that going forward, as we move forward, these will be more and more shifted on the 5G, and 5G will bring a huge revolution in the process automation in the manufacturing sector. Then the remote monitoring of production assets, so operators don't have to go be on the floor all the time. They can manage the operations remotely, and they can gain actionable insights directly for multiple floors sitting remotely. Collaborative robotics, I spoke about it briefly. I think 5G will make robot use in manufacturing much faster, and it will bring exponential growth in robotics. Breakdown predictions, AR, VR for repairs and drones. So there are limitless possibilities when it comes to 5G use cases in manufacturing. Now, if I bring it to the Indian context, the large industries or the large manufacturers will obviously have the both the financial as well as the knowledge wherewithal to adopt this in their manufacturing setup. But the real challenge comes with small and medium enterprises. So today we have more than 63 million small and medium enterprises, which contribute to about 33% of our manufacturing produce. So how do we take 5G to these small and medium enterprises which do not have or who don't see an immediate benefit of this, and who don't have the financial wherewithal to adopt 5G? So what is the solution for that? Obviously, it is about taking them the relevant applications, but three things: 5G, which will bring connectivity, cloud, and security. A combination of these three things, when we will take to small and medium enterprises, then we need to show them the benefits before they start adopting it. So basically, the Ministry of Micro, Small and Medium Enterprises has already a scheme which is related to micro and small enterprise cluster development, in which these MSME clusters, there is a small setup which is getting deployed, or it's planned to be deployed, where new technologies can be tested. And here in these common facility centers, the MSMEs in the clusters can come, they can set up their advanced machinery, they can do training, they can check their production processes, they can validate it, they can understand the benefits before taking it to their enterprise specific deployment. So what we believe is that if the government or the Ministry of MSME adopts 5G as a inherent part in their trial clusters and in their technology verification centers, 5G as an inherent connectivity technology together with cloud-based applications and security, then this can take the 5G into MSMEs into a very large scale deployment in India. This is something which the world has been lacking, and with the right support from the government, I think the 5G adoption in MSME can be quickly accelerated. Moving forward, coming to logistics, similarly, these are the use cases which have been spoken about earlier. Fleet monitoring, navigation, inventory management, ports modernization, and V2X communication have already been spoken about, so I will not dwell too much into detail. But what is it that we can do when it comes to 5G use cases in logistics in India? So we all know about this Gati Shakti program, which entails on the 7 engines, mainly railways, waterways, roads, airports, ports, and logistic infrastructure. So the whole objective is to reduce the cost of our logistics, and how 5G can bring about. I think the time is short. Otherwise, in each of these 7 pillars, 5G can bring in massive transformations. So if I speak about railways, there is already a program for signaling modernization to accommodate more trains. I think if we bring 5G in, one, we will be leader in the world. Second, we can always allow more trains to run on the same track. The railways have an ambition, by the way, to today the railways contributes about 33% of our goods movement, and their target is to take it to 50% by 2030. Now, a 50% contribution to domestic logistics cannot happen without modernization, without use of technology and upgradation of the signaling system of the railways. So I think 5G can play a major role there, and we can be leaders in the world when it comes to that. Similarly, ports. So our 13 major ports today contribute to about 70% of our import and export. And these ports, there was a massive program by government in 2016 called the Sagarmala project, using which we tried to modernize our ports and bring the cost of logistics down. Just to share a simple statistic with you, our ship turnaround time today is 4 times the global average. And this entire time when the ship is standing at the port and not able to turn around is actually incorporating into the logistics cost. Now, how do we achieve this fast ship turnaround time? Just one of the major KPIs of the ports. Technology and 5G can play a major role here into various aspects of port operations, process improvement, automation, right machinery at the right time, and so on and so forth. So the push that we need to do as India is to imbibe 5G as a core connectivity technology combined with the edge computing and the cloud, enabled by network slicing, to modernize our logistics infrastructure across all these 7 pillars. If I talk about then across them, if I talk of a multimodal transport, even there, simple use cases like container tracking. Let's pick up a very simple use case of container tracking. So today, our container tracking is, one, it's fragmented. Second, it is very difficult to track your shipment end to end, because it's difficult to track a container on a wagon, for example, on a train wagon, because there is no power on that wagon. Second, there are problems in the container depots on where do you track vertically and horizontally each container, and 5G with its location accuracy can bring massive use cases into that. We at Geo believe that if we bring 5G into these 7 engines of logistics in the country, we can reduce our logistics costs significantly and make India truly competitive in the logistics sector. So these are just some of the use cases which I already spoke about. Another use case could be on the road safety, but I'm not going to discuss that in too much detail. And there are already huge success stories globally on 5G in logistics and manufacturing, where the time to locate the goods has been brought down, where the logistics cost has been brought down globally. People have already seen the benefits. I think the true test for us will be how we can imbibe this technology in our Indian relevant context, deploy it on scale with our MSMEs and across our multimodal transport to bring down our manufacturing and logistics cost so that India can be truly competitive and we can adopt 5G in its truest sense. Those were the only things from my side, sir. Thank you so much. Shri Vinay, over to you.
Thank you, Rajiv ji, for wonderful presentation. There are a few questions, rather one question and one supplementary question by Mr. Paul in the chat box. Before you move on to your next meeting, I request that if you can answer in the chat box itself, although I tried to answer, but you can supplement there.
I will do that.
Yeah.
I will do that right.
Thank you. And many participants are asking for the presentation. In case it is possible for you to share,
I will share
with us. Maybe after truncating whatever is not possible for you. and
Sure.
give it to us so we share to our registered participants. So thank you, Rajiv ji. Next in line, we have our speaker from Vodafone Idea Limited, Shri Amit Rao, who is General Manager VIL. So over to you, Mr. Amit. Amit ji, if you can. I see Amit is not in the presenter list. Vinay, can you talk to Mr. Amit if he is around? Okay, I see.
Yeah, thank you.
Okay.
I was not able to present. Just a moment, let me share my screen.
Yes. Yes, we can see your screen, Mr. Amit.
Yeah.
Yes. You can go to the slide mode. Yes.
Yeah.
Thank you.
Yeah. Thank you so much, NTPRIT team, for giving VI an opportunity to showcase our use cases. So let me go slide by slide. Okay, so we are doing this trial as DOT has given us spectrum in C-band and millimeter wave. Basically, we are doing this trial at two locations. One is in Gandhinagar, along with vendor Nokia, and the other is in Pune with Ericsson. We have we have demonstrated many use cases in the real world scenario. We'll go through each of these use cases one by one. Actually, we demonstrated these use cases under the Atmanirbhar Bharat theme. We also did this with our vendors Ericsson and Nokia. To give us a better understanding of use cases, I will also play short videos, interesting videos of each of these use cases. Basically, the architecture for our trials is what you can see on the screens. We have on the field deployments, we've done deployments in tunnels, we've deployed in cars, schools, playgrounds, on the streets. And from those locations over our VI 5G network, we took the data towards the data center where we have the multi-access edge computing present, and then to our demo locations. So we need to kind of remember this slide because all our use cases have been done on this slide, following this slide. So basically on the EMBB part, as Dr. Alam, the speaker before us had pointed out, the famous triangle out of that on the EMBB part, we've done peak speed tests. So on C-band, we got a peak speed of 1.5 Gbps, whereas on the millimeter wave band, we got a peak speed of 4.2 Gbps. This is just to show you the capabilities of 5G. Now we'll start with the actual use cases. Dr. Alam had referred to digital twin in his talk. So basically, I'll be presenting you what digital twin is and what we've done in the digital twin area. We did this use case in Pune Metro. There's a Swargate metro location. There's a big tunnel there. So we went into that tunnel, put up 4K cameras there, and over the VI network, we relayed it back to the core, to the data center, just as I showed it in the architecture diagram. So we had many 4K cameras over there, and those cameras were used to create a holographic image of the tunnel. I'll show you the video which will make it more clear. Are you able to see the video? Hello?
Yes, but no audio.
Yeah. So this is the actual site data which we have. Athonet is the vendor here. So we Athonet had taken the video shootings and created a holographic image of this site of the Pune Metro Tunnel. You can see the people over there. The cone is showing you the number of people there. So this is the tunnel. You can just peep into the tunnel and see. And the guy who is seeing this is at a remote location in an office. He's not there at the site, so he can see what is happening in the tunnel. As you can see, the elevator is coming down, and you can also see the shaft here. Since this is a tunnel, you can also see the tunnel boring machine in some time. This is the tunnel boring machine. So just to give a feel of how this will happen, we've demonstrated a case of fire. You see the something is burning here, and the supervisor who is sitting at the remote location is telling the worker to take action on this fire. This is the actual demonstration which we had done to DOT officials sometime back in November. All this is visible through a hollow lens, which you can also call it an ocular lens. You can see a digital representation of the complete tunnel at a central site here. I'll just run through this video. This is the actual location of the tunnel. Okay.
Someone is asking whether it was a real time.
Yeah. This was real time. This we had demonstrated sometime back in November. Okay, so coming back to the next.
Which place this demo was? Which place this demo
This was
was
in Pune Metro Tunnel.
Okay. Now I remember. Yes. Please go ahead.
Yeah. So the second use case is the connected worker, which is kind of a, if you want a smart workplace. In this, if you see, this takes care of the pandemic time situations where we had to do social distancing, where we had to put up a face mask. So all those things were captured here. I'll just go through each of the test cases here. So with the connected workers, this is one use case where you can see intrusion detection. So this here is our BTS site, and this person is not allowed to pass this blue band. So if he passes this blue band, it will show a violation here. It will also give an alarm to the control center saying that somebody has breached this band and is a threat. There can also be a hooter which can be placed there. The other use case for the connected workers is the number of count of people. So during the pandemic times, all the offices had a specific attendance system where 50% of people had to come. So this would give the attendance. It would count the number of people there in the office. So Athonet had tied up with Make Computing for this software.
So is it on 5G network or any other?
Yes,
network?
yes. Everything is on 5G. See, these cameras are 4K cameras. So 4K camera in Pune. Again, this is a social distancing use case. If you see, if a person is near to the other person, it will show you in red, and it will also give out an alarm so that the supervisor can call him and tell him to maintain the social distancing. Okay, I'll go on to the next use case. This is an interesting use case of aerial traffic management. UTM is unmanned traffic monitoring. This is a startup called Visby. This is a drone-based technology. Basically, they have a drone which is fitted with a 4K camera, and it can do lots of things like public safety, law enforcement. We'll show you the video where it will be much clearer. So this is the drone which is flying. So just for this video, this part, we've done this on the 4G. The range is around 300 meters here. But for the other parts, this part is on 4G. But for the other part, we've used 5G. So what this drone is doing is it is taking a aerial picture of the area where it is flying. You can also put the coordinates into the drone. Yeah, you can see here, you can put the coordinates into the drone, and the drone will take whatever is given to it to that specific location. Suppose you have a flood situation where you need to give some medicines to the flood affected people. You just have to put in the lat long of that place, and the drone will carry the medicines to the flood affected area. So what this was showing is that it can also monitor the obstacles. It will not go and hit a tree. It will not go and hit a building. It will take the other route and go to its location, final location. All this you can do it on your on a map on an app from your mobile.
So how
Okay,
your
this is
signal goes towards up direction? So you have to put some antenna towards up direction or on higher altitude?
no. This is not. I mean, this was not running very high. It was like 2 or 3 floors above for our use cases. Once we have a bigger network, it can go up to 300 meters or so. So this is one more of the application use case of the Visby. So basically what we are doing here is we are monitoring the cell site. Basically the drone is fitted with a mobile phone which is on 5G. It will take pictures, and it will also see uh, 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 during the range, basically the winds are high. So if the antenna is moved, it will check whether the antenna azimuth has changed or not. It can also give a radiation map. It will show you how much is the transmitted power, and it'll show you a heat map from the system. Okay, now coming on to the other use case, which is public safety. This was done in collaboration with L&T. Even here we use the 4K HD cameras streaming through our network to the MEC at the data center. As you can see here, this is the Fusion software. which L&T has made. And this is a use case where you can see a man who is traveling through a woman only area. You can specify zones for men only or women only. So if it is a woman only, and if a man is coming over there, you will be able to give an alarm and say that this is not the right guy who's coming there. If you see on the top here, we did this in the night time and we did this in the daytime also. So both the cases are working here. The other use case is the lone woman, which is kind of suppose if a lone woman is walking on a street and there is nobody there, so an alarm will go to the law enforcement agencies to take action. They'll come and either they'll call her or they'll help this woman by taking action. The other use case which we have is smart and connected health. So basically, we have a connected ambulance. After an accident, the first 1 hour is called as the golden hour. So because during that golden hour, we need to connect to a doctor and get information from him. We need to know where we have to take this patient to, what is his problem, and how do we diagnose it. So for that, we have this use case. I'll just demonstrate this to you. If you see, the patient is lying in the ambulance, and on the app you can see his vitals coming up, and we have an ECG device. The ECG device in the ambulance is connected via a Google Meet to the doctor who is sitting in the hospital, so he can see the ECG and guide him. If he wants to ready the operation table, then he can immediately do so that no time is wasted after he comes to the hospital. Suppose he is not the specialist, he wants to send this patient to some other hospital, he can tell him, he can guide the ambulance driver to go there. This is one more indigenous use case from Tweak Labs. This is full body motion capture system. Basically, what this does is, suppose this is for sports. This is a sports use case. So basically, what this does is it will capture events. I mean, if a bowler is bowling, it will see whether the action is correct or not. So the bowler's body is fitted with sensors, and the sensors are Wi-Fi enabled. So currently these are not 5G enabled. They'll be doing this 5G enabled. So the Wi-Fi sensors will tether it to via a Wi-Fi device through our 5G network to the MAC server. So this is the device which the bowler is putting on his arm. So this is an app which is there with the coach, and he can see each of his delivery and his bowling action. He can also give him remedial measures.
Very nice. Amit, if you can quickly sum up.
Sorry?
I was just saying if you can quickly sum up so that.
Yeah. Okay. We also have this remote diagnostics. In the remote diagnostic, we have this connected glove, and this connected glove has a haptic feedback here. You can see the doctor here. When the doctor is moving this joystick will give haptic feedback to this glove, and the paramedic who is at the remote location can check, he'll know which way to go, whether to go forward or backward.
Now, 5G will enable services like remote touch will enable remote movement in real time. And this is a very significant change to potentially facilitate a global shift from real-time to real-time interaction. This demo carried out by me together with Ericsson showcases the real-life application of real-time communication in the health industry, enabled by adding a data channel inside voice, video communication, and text channels. So, a doctor from a hospital performs an ultrasound scan remotely in a patient who is in some rural area. The doctor is assisted by a paramedic who is wearing a connected glove with haptic feedback. This allows the doctor to control the paramedic's hand remotely and thus conduct a remote ultrasound procedure in real time with live video communication.
We also have this automotive driver monitoring system. Basically, this will see if the driver is drowsy, and if he is drowsy, it will raise an alarm. If there is an hooter here, the hooter will also sound, or the alarm will go to the fleet management system. Okay, we also have demonstrated the use case on the roller coaster gaming. This is the cloud gaming. Basically, you have a guy who is sitting here on the chair, and behind him you have a sensor, Kinect sensor. The sensor is connected to the Kinect server, which is connected to the gaming server. So if you raise the hand, your game will start. We'll just quickly go through this.
Cloud gaming, where gamers can stream and play high-end games without investing on high-end consoles or resource-hungry gaming software. That's where 5G comes in. High data speeds, over 3.5 gigabytes. Game starts, raising your hand, the movements are captured in the device behind the user connect, capturing the movement. Just needs to ensure to make the roller coaster goes to the correct direction of the objects coming in between, like chocolates. You need to avoid bombs.
Okay, we'll go to our next use case, which is the 360-degree virtual experience. Basically, we have pre-recorded.
I request Abhijit if you can share the PPT, which you can share with participants, because
Sure.
We have few, upcoming sessions, no? So time is the limit.
Yeah. Okay. Just give me a minute.
Or you can sum up in next 1 or 2 minutes.
Yeah. So we also have this intelligent video surveillance, wherein you have 360-degree cameras here. You can take a picture of the guy who is coming in your office, and it will be recorded. So if an intruder comes, it will give you an alarm. The last one is the connected classroom. Basically, this is for the rural areas where children in the rural areas can get quality education from teachers in the cities. So basically, the children will wear the ocular glasses, and the teacher who is in the city will have a camera which is placed here, and she'll be able to teach them. So all these are the use cases which we have done. That's all from my side. Thank you.
So thank you, Amit ji, for wonderful presentation, particularly the real use cases which you showcased, which you have actually rolled out and demonstrated as part of your POC. So thank you so much. There are few questions on the chat box. I request that you answer in the chat box itself. In the meantime, may I request Shri Abhijit Chaudhary, who is CEO NeuralNet. So Neural Network has actually rolled out 5G core network and other solutions. So may I request Abhijit to kindly present. Over to you, Abhijit. Yeah, we can see your screen, Abhijit.
Can you hear me?
Yes, we can hear, and we can also see your screen.
Okay, great. Yeah. Good afternoon, everybody. First of all, thanks to IPIT to actually showcase our product and also the use cases. Thanks for that, and hope we'll be covering some of the use cases for the private 5G, which is our focus, and get feedbacks to you later on that. When we talk about connectivity, I mean, we have gone through, I mean, we are presenting at last, so we have covered a lot of the introduction, but I'll quickly summarize my initial slides, which are already covered. Till now, what we see, I mean, with the existing network, which is over Wi-Fi or 4G and Ethernet with cloud, is that we have actually been able, this solutions with 4G or Wi-Fi with the cloud has actually disrupted a lot of applications, like we know of the taxi booking or the delivery application. They had placed, it has helped us as a consumers to digitize or get real-time feedback or book a car, etc. It has been disruptive in that way. And these applications which has been disrupted are generally on the consumer-facing applications or the IT applications when you talk about Zoom, etc. In fact, the call we are having now is through my Wi-Fi network, through the Azure cloud. So, I mean, these are the consumer-facing or the IT applications which has got disrupted to a lot of extent. And when you look into such applications, they are generally non-real time. I mean, and non-reliable, and it can be a little higher latency because it goes to the cloud and it comes back. So you don't need, you need a real-time feel, but it need not be exactly having a low latency, like maybe 10 millisecond or 1 millisecond. You can go ahead and have a little higher latency because it has to go to the cloud, which may not be within the control of the operators, or you cannot give the QoS required on that, but still you can have a good fill. Similarly, if the network need not be reliable, like you are trying to book a taxi and like your Wi-Fi goes down, you can just switch on your 4G and again book. Then because human is controlling, we as consumers are controlling, and we as humans, our reception, our sensors, human sensors are not as low latency, which we can actually have a little more latency, and we can also adapt to the requirement, which probably the machines cannot, and that's where we would come to. So now when you come to the communication or connectivity which needs machines, like when you talk about manufacturing, warehouse automation, oil and gas, shipping ports, mining, or smart city. I mean, these are huge areas. You need not only connectivity, also you need to ensure like mission critical, reliable connectivity. You cannot have, okay, the Wi-Fi went down or the 4G went down. Or you cannot have a higher latency, like maybe 100 milliseconds for the cloud to respond back and you take a decision. Even some milliseconds of delay in getting the output to the device can cause a major calamity. So these are mission critical industrial operations. And for that, the existing connectivity using a Wi-Fi and a remote cloud is not good enough, and for that we need different kind of solution. I mean, we have already talked about the 3 pillars of 5G, and I'm not going to cover that, but what I'm trying to show is that the applications and what they need. Like when you talk about, I think Vodafone, I mean, we saw some real use cases that was really exciting, and it kind of helps me to explain better now. Like when you saw the video monitoring with the AR, VR kind of applications, you need really high bandwidth because you have to send, I mean, the videos. But at the same time, you also need low latency because you have to adapt first for remote operation. Like so that kind of things, applications or the use case based on the application, you would have a different kind of requirement. Like when you go to like smart city or industries, you will have a lot of IoT devices to be managed. So you need like within a, like I've given discussion that we are having with the oil and gas plant in Middle East Asia. They told that within their oil and gas plant, they have around 1 million sensors that has to be managed. So that's the third part of the pillar, which is massive machine type communication. So where within a square kilometer, you can manage 1 million devices using the kind of architecture which the 5G provides. But to overall ensure this high latency, high bandwidth, low latency, IoT, massive IoT, scalability, and ultra reliability, I think 5G is very crucial. But along with that, we also need to have an edge story, and I think that was already mentioned in the previous by the previous speakers. So all the applications that you see here, most of them would need 5G, and some of them definitely needs an edge, which has to be very low latency and within the premises of the enterprise. Some of them can be a little further, but you still need an edge to ensure that you have control over the latency and it doesn't really go always to the cloud, where you may not have a control on the quality of service and the latency. And this is how the emerging industrial applications are coming up. So the cloud has got divided into multiple edges. You can have an aggregated edge, and then you can have on-premise edge. And that would be a lot of focus on on-premise edge in my talk today, and on-premise edge with 5G, because we want to enable low latency. So we talked about the taxi web app in the previous section, which was a consumer-facing application for logistics. Now we are talking about robotic automation, which is a operational, like industrial operational application, again for logistics, especially for, let's say, warehouse. So here, to run this application, you need to have an edge. Basically, the compute has to be done on the edge, especially for the vehicle management, or you can say the video cameras connected to that to take a decision, the analytics, all those things, decision compute has to be done on the edge to ensure low latency on the range of like 1 millisecond to 10 milliseconds. And of course, for high bandwidth to send videos, and like there are like maybe hundreds or like at least 50 devices within the warehouse. So all the data going in, compute and coming back, you need a high bandwidth solution and also reliable solution, which 5G can provide. And this is the transition that I was talking about earlier, like and reiterating that, like moving from the Wi-Fi plus cloud to the 5G, especially private 5G plus edge for industrial grade operations. And this is a huge market. I mean, each of them have a different kind of numbers, but like one of the numbers that I have from KPMG is like $517 billion. It's not only the industrial operation, but the AR/VR and the energy monitoring, transportation included all together. It's a huge market to be disrupted and growing at a CAGR of almost 40%. Yeah, so I'll cover a little bit on the network architecture now before diving into the use cases. Traditionally, maybe I won't say 5G core here, but traditionally, if you see the network, especially from the TSPs, has been like you have a lot of disaggregated radios, and all of them get connected to a city-wise core or a sector-wise core. Like you have a centralized core for each sector, and you can have all these radios connected through that. And from the operator, like it can be, if you are connecting through the radio, of course, the 4G network, then through the operator, you can go to the public cloud. Now, when you talk about the 5G, especially with 5G, how the deployments are rolling out, even in the operator's network, I don't think the slide that I'm showing in the top, that is not how it is getting deployed, but by default itself, it is having a concept of edge already, and it has been spoken earlier too by the speakers. So we have the 5G core, which can be a centralized core, but you also have a local breakout through an edge application or an edge compute provided by the operator at different places to ensure that the low latency is taken care of, or the QoS altogether. So you can actually, if you are running you are connected to a 5G network from the TSP, you really don't have to send the data from the radio through the transport network to the core and then go to the cloud, which would increase the latency. So lot of the applications that would be running on the TSP's network would also go from the radio to the edge, which probably an aggregated, a community-based edge that the operator would have. And from there, you can go to the public cloud, or it can be processed locally in the edge compute box, which is running on the same. So here, what it will happen is that the 5G traffic, which is actually traditionally, or on the technical language, taken on a GTPU transport, it gets converted into IP by the 5G core, which can be a user plane 5G core. I mean, you don't need to run the fat 5G core, which is running on the centralized location, but a lightweight 5G core, which will only do the user plane processing, not the control plane. So the 5G traffic gets user plane traffic gets converted to IP traffic, which is like a normal IP packet, REST APIs, all those that we send. So that goes to the mobile edge compute, and the processing would happen, and you will get the response. In some cases, of course, it can go to the cloud. But that is how we are slowly, even the TSP's network, I mean, it has been already discussed. We are looking at low latency and to enable real-time kind of applications. Also, there is an emergence of private 5G. Now, how it is implemented, I'll cover in the next slide, but where within the enterprise or within the on-premise itself, you can run a 5G core. Again, it need not be a heavyweight 5G core. It can be a lightweight 5G core, or only the user plane of the 5G core can run here. And the enterprise can run their applications within the private network itself. So that is sometimes important, especially like a lot of industry doesn't want their operation like data to go into the network, right? Public network. It is very crucial to keep it inside. So the privacy and security is very important. Banking, like operation, industrial, that is very key. And sometimes the amount of sheer bandwidth of video data or like the data of the operation data may be too much to send to a public network, even if there is an edge. So it's always good to process it locally in the local LAN. And that's where I think the private 5G is coming in. And I personally feel that would be the real monetization of 5G overall. And there is huge use cases running that can be done using these private networks. Now, coming to the private 5G deployments, which is actually a key focus for Neural and overall, I think this seminar too, is that private 5G can be deployed in predominantly 3 ways. The one, and it has been already discussed, is like the telecom service provider, use telecom service provider spectrum, and within the enterprises, because you have multiple enterprises, that the radio, the 5G MECs would belong to the TSP's network. But to guarantee a kind of like the latency which private 5G guarantees, I mean, as an architecture, so the TSP would give each of the enterprise a separate network slice. Network slice, if you are traditionally from an IP network, you know a virtual network, right? So you are creating the TSP is creating a virtual network for you using the network slice with guaranteed QoS to run your applications. So that is the traditional, I mean, that is the one form of private 5G. And the second one is that, okay, so the TSP again would manage that. The spectrum would also be from the TSP, but there would be a local breakout. And to ensure privacy of the data, I mean, the enterprises can run their MEC applications and even the 5G core which is running on the enterprise can be from the enterprise or can be from the TSP also. But definitely the Mac, the edge applications would be from the enterprises, because they don't want data, their user data, operational data, video surveillance data, etc., to go to the cloud or to the public network. So that is what I call TSP private 5G with a local breakout. So here again, the spectrum, everything is from the TSP. However, the 5G core may not be TSPs, especially the user plane. I mean, of course, the TSPs manage the control plane, like your authentication and then like the control plane management. But the user plane, like the data coming after the control plane or the sessions are established, can be a software core which can be actually given by the managed by the enterprise too. So here, good thing is that seamless handover would work from the 5G TSP's 5G to enterprise, like 5G, if I call it so, network. And the last one is where the enterprise actually manages the private 5G network. And here, the spectrum or even the radios, all of them can be managed by the enterprise. So they can, in US, there is a concept of shared spectrum, CBRS, which can be used by the enterprise to manage the network. There is a lot of work going on unlicensed spectrum, which would be on the 5 gigahertz or the 6 gigahertz, similar to Wi-Fi. There is a lot of push on that, especially with the private 5G becoming very critical. And a lot of survey telling that private unlicensed spectrum would also play a critical role. It will take some time because devices, I mean the user end devices, maybe the drone or the robotics, would take some time to work on the unlicensed spectrum. So maybe another 3-4 years, maybe more. But there will be huge disruption, like if that happens. I mean, where you can create your own network on the private, on the unlicensed spectrum. The other, of course, is that the enterprise can buy the spectrum from the government. So enterprise has to pay an annual fee for that and buy that. Even in the shared spectrum, you have to pay to the government or a regulatory authority. But then once you have the spectrum, the enterprise can work with various stakeholders or a system integrator to create the radios and like the 5G core and the MEC and manage their own network. In this case, if you are not tied up with a TSP, of course, there may be some issues of seamless handover. I mean, your 5G phone, when you move out of the enterprise to the TSP, you have to reconnect probably. Your phone call may not continue if you are doing. But yeah, if you have an agreement with the TSP, that would still work seamlessly. So it depends on how you kind of work. But here the control is with the enterprise, like total control. So neural networks per se, we are focusing on the B and C categories. And yeah, I'll just run through quickly. And I mean, when we talk about TSP with a local breakout, what happens is that the centralized core, which would be run by the operator, would be doing the control plane, and telco would have their own cloud too. But the enterprise can run a local breakout with a user plane and their edge applications too here. And otherwise, the other option is, of course, a totally private 5G solution where the control plane and the user plane and even the Mac applications, everything is residing within the enterprise, and enterprise has full control. I would quickly move through now in the interest of time. I'll try to summarize in 5 minutes. So yeah, I mean, we as a company are focusing on a very software-centric stack for the 5G core and the edge infrastructure management, which I think is very important. And we work on any commercial off-the-shelf hardware. Your existing hardware also you can run there. And we work with like our partners who can be TSPs or the radio providers, etc., who provide the radio. So we actually provide the core and the controller and the edge management infrastructure. We do not provide the edge application, that would be third party, but we provide the core and the controller and the edge platform. It's a Kubernetes-based edge platform that we have, on top of which you can run your enterprise applications. Yeah, what we see in the long run too, there is a huge movement to private 5G as a service through the operators, through the cloud providers, and maybe with unlicensed spectrum coming up, that would become a reality. I mean, ubiquitous, I would say, and that is something we should look into. And it would take some time, but there is a movement into that where you can create a private 5G network and multiple such networks, and you can manage it from the public cloud, like how AWS does that or Azure does that. But I mean, of course, the infrastructure would be within the enterprise, not actually in the cloud. So it's kind of different that way. But you can manage it from a centralized location. The use cases has been already covered to a large extent, so I'll not focus on that. But one thing I wanted to talk about the ROI. When you have an edge compute, it would ensure that like when you have a drone or autonomous guided vehicles, robots, etc., right? If a decision has to be done independently because the connectivity is not good, it's not high, doesn't have low latency or high bandwidth, then a lot of the decisions whether the robot should move left or right has to be taken by the robots themselves, like a Tesla car. But then it would need a lot of CPU, RAM, hard disk. The cost increases for each device. Now just think you have 100 robots within your warehouse. The cost would really be 100 times because of this high requirement of resources. Now, if you have an edge compute with a cloud and running an edge Mac within your enterprise, then actually the devices, the robots or the drones, etc., they need to collect the data, but they don't need to process it because the processing would be done on the Mac. What they need is a low latency, high bandwidth connectivity. So all the decisions, whether the robot should move left or whether there is a traffic red light within the warehouse and you should not move, those decisions would be done in the Mac. And the main duty of the robots or the sensors is to collect data and send through the low latency, high bandwidth connectivity. So that would drastically reduce the cost of each of these devices. And also low power, because you are not doing any analytics within the devices itself. Yes, I mean, when you talk about logistics, and I think outdoor mining, oil and gas, ports, I mean, this diagram kind of summarizes that you can actually digitize that. There is a huge need of digitization in mining. I mean, still there is traditionally, especially in India, they go in the mine and sometimes they go inside the mine, collect the data on a USB device for all the IoT sensors within the tunnel, within the underground tunnel. And then they bring it back to the office and then see what is the condition, monitoring. So that is the kind of, because I mean, mine is a huge area, right? And it's also underground. But using 5G and edge compute, you can digitize the full thing and you really don't need manual intervention. Whenever a blasting and all those things happen, the drone can go inside and like do the necessary prevention check before a person goes inside, or collection of the mining data. Similarly, when you talk about indoors, and it was already covered, so I'll not speak in, with the drones and the robots, you can manage or digitize your warehouses. This is a real scenario use case for manufacturing from Fujitsu, where they have they have automated a manufacturing plant in Omoya, and they're using the 4K videos and the automation. They are using private 5G to monitor that. Yes, sir. So I'm done.
Yeah, thank you.
Yeah, so this is my last slide, and summing up onto that, especially on manufacturing and logistics, you need unmanned automated vehicle and management for that, and 5G can provide the connectivity. In fact, it can increase the productivity of mining oil and gas through that by 30%. Then you talk about autonomous drilling, robotics, ventilation. These are very important in like mining oil and gas, etc. So it will help people to save lives and like also increase productivity, reduce the OPEX cost. The drone and the video surveillance use cases were already shown. It can help you to remotely operate and manage your like sites. Device monitoring is very important for preventive maintenance and increasing the productivity. And lastly, what I feel is that private 5G or 5G as such would be very important to connect the unconnected, provide quality education, because you can have an edge running with the 5G core and within a village, I mean, which is probably not the use case we are talking now, but provide quality education, healthcare, employment too with using that. So these are very crucial use cases where we can look into 5G overall. And yeah, so this is what I have to cover today. Thank you. And
thank you.
Yeah.
Thank you so much, Abhijit, for a wonderful presentation. And what we understand is like as a startup, you have built a 5G core network which can be deployed as a private 5G in all the use cases of the vertical. So thank you so much for this presentation. And at the last moment, we also have a very eminent speaker from Airtel. I'll just introduce him and then hand it over to him. So with us today, we also have Mr. Madhur Bhardwaj, who is Solution Head 5G Enterprise, although confirmation came today early morning. So we included. So over to you, Madhurji, for your presentation. Kindly be quick because we are already running slightly, late in the time. Over to you, Madhur. Madhur, are you around? Just unmute yourself. Madhur, you need to unmute yourself. So Vinay, if you can speak to Madhur, he's not able to open the.
Sir, just a minute, sir. Just a minute.
In the meantime, I would request Abhijit, there are a few questions in the chat box if you are able to answer in the chat box itself. Madhur, if you are around, please share your presentation. In the meantime, we have one raised hand by Mr. Karthikeyan. So Karthikeyan, you can speak if you want. Your mic is on. Just ask your question. Karthikeyan from ITI, you can unmute and ask your question. I
Sir,
think
just a moment, sir. Madhur sir is with us. He's having some difficulty with his mic, so he's rejoining the meeting. So within a minute, he will just.
Abhijit, there are a few questions for you. People are trying to interact with you. Kindly do so.
Hello, sir. So I'm not able to actually access the chat. Like I'm able to the latest chat. I'm not able to see that.
Okay, I'll be putting the questions in the WhatsApp. You can answer and I will post.
Okay, that will be.
Yes, now I'm
again. Madhur, can you share your screen?
Yes, sir. Sure. Sorry for this glitch. Yeah. So first of all, thank you NT-IPRITs for accommodating this request at the last moment, and thanks to all my peers who have already covered most of the things, and I have this allows me to remain very sharp and focused around my messaging for 10 minutes. To introduce, I am Madhur Bhardwaj. I am Solution Head for 5G Enterprise. I work closely with the enterprises for their business solution needs, and during this 5G trial period, Airtel has worked very closely understanding the requirements of the industries and then converting them into some of the use cases where some tangible benefits and ROIs can be envisaged. So since most of the technology side of aspects, architecture side of aspects have been covered a couple of times already, my slides would remain focused around some of these solutions and the use cases for the industry. So first of all, what is the industry expectation from the 5G as a technology? What 5G brings? We all know 3 pillars: EMBB and MMTC and URLLC. But in terms of the business benefit, I don't think that enterprises are looking for only a technology upgradation, but they also look for what they get out of that technology benefit. So I think these are some of the areas. While talking to most of these enterprises, we realized that they are looking to achieve higher operational efficiency. They are looking to find out ways and measures how they can improve quality of their products, how they can be more cost savvy, how they can be more productive and competitive in the market, how they can have increased workforce productivity, can have better safety and surveillance mechanism, and how this technology can help them doing a faster product launch. So these 5-6 areas came out repeatedly with most of these industries, and we thought that these are the areas where definitely 5G can play a role. We had a wide coverage around industry, so we worked on use cases for manufacturing, mining, healthcare, entertainment, ports, retail, etc. Some of these use cases we also demonstrated to TRI and DOT and interministerial team at our Manesar facility. Coming to the logistics and warehouse use case, one of the use case, first we worked on identifying the problem. Now, one of the things that I keep hearing, and most of you, is what is the use case? And there are some of the use cases which are maybe pre-casted, prefabricated, and maybe have been achieved in some geography already in some industry. And sometimes it is like you just bring a one size fit all kind of a thing and you try to just copy paste this to other industries. So I don't think that that's the right way of doing the things. Here, we need to work very closely with the industry to understand their real-time business problems. We need to understand their challenges, and it can differ from industry to industry, geography to geography, business to business, and operations to operations. And we realize this in very, I would say, very clear manner when we interacted with some of these industries that yes, these solutions or these use cases will be highly bespoke or customized. Now, one of the problems of this warehouse industry is that this is manual in nature as of now, and there is a lot of scope of to do this digitization in this warehouse use case. My friend from Neural Networks was talking or touching upon this point, and I agree with him. Now, think of a warehouse which is spread across acres and they have a stockpile to serve for months of deliveries. Having a real-time view of the inventory in terms of their geographical locations or the quantities is a huge challenge in this industry because it changes dynamically every minute, every time, and they have to deploy sometimes even hundreds of people simultaneously to take a stockpile of the situation, and this accuracy of their inventory at best, what I have heard from these industry leaders, have been to 70 in the 70s at best. Now, how we can reduce the manual effort here, how we can digitize it, how we can automate this so that you can have a real-time location plus quantity view is by using of drones. Now, how we can apply on each of these racks, huge stack pile of material, by digitizing the first component, that is applying a QR code on each object, something like that. And then how these drones enabled with a camera can scan those QR codes, can take a measure of the inventory, and using a 5G modem directly or a 5G private network can send the information back to maybe an on-premise server or a public cloud server in the inventory management sheet, and then they can update the stock as is seen in real time. And by doing this, you can have maybe some 10s or 20s of drone flying at the same time, and within 2 or 3 hours of operation, they can bring a real-time inventory to the greater degrees of 90% with this much accuracy. And when I'm talking about this, there are some numbers that we have came to know from some customer who has applied it in their manufacturing plant and the inventory that they were managing. And these are some of the result in terms of 9% accuracy increase within 1 month's time frame, 80% reduction in duration of cycle count, and 80% reduction in manpower and safety risk. So this is a huge challenge, and this you are solving a bigger problem of the industry, and it is easier to monetize. It is easier to help in operational efficiency, and this industry will have, I would say, an affiliation for such kind of use cases. So the baseline remains that yes, we need to understand the problem at the base and then work on stitching a solution, building a solution, and then with the help of technology, taking it back to the customer. The second part is manufacturing, and with manufacturing, there is a statement or a quote that the further a defect moves downstream, the more expensive it is to fix. And expense is not always monetary part. It can be expense at the cost of your brand image as well. So think of something that a wrong product goes to the market and then you have to make millions of products call back, and that happens very often in car industries and some of the industry that we know of. How you can stop this? Because this leads to millions of dollars of revenue leakage and sometimes even the loss of brand image as well. This is a huge problem to solve, and some of it can be solved on detection of product anomalies during early stages of production. So once the product is getting produced, how you can analyze, capture the image or the video of the object, can analyze it in real time and can give a feedback in real time to the factory floor shop managers or in an automated way to the assembly line, so that a decision can be taken either by a machine or by a manager. And those products where you have identified the fault can be treated to a different rail altogether, and the products which qualify can go to a different rail altogether for further processing. And then you can always take real-time decisions, like factory manager, once he sees that there are a number of products which are coming faulty, he can stop the production instead of creating a dead stock or a huge pile stock of wrong products. And this product, we are seeing that this particular use case is having a huge demand in each of these industries and will play a major role, video-based analytics or computer vision-based use case in the manufacturing sector for sure. So 5G wireless, how 5G helps in this? Maybe 1 minute on this. 5G brings in the real-timeness in this because of its nature of giving you a feedback within 10 to 15 milliseconds time frame, end-to-end latency I'm talking about. And then also 5G helps you with uplink of higher data or video images, many cameras working in parallel. It also allows for higher bandwidth catering by virtue of this network. And third thing is, by being wireless in nature, it allows industries to scale their operation without thinking on complexity of architecture, design, higher capex spending on switches, routers, and higher time spent on bringing in terms of a downtime. So wireless gives them a lot of flexibility. With Wi-Fi, they face a challenge of interference and other mobility related issues. The use cases won't scale where mobility is more involved. So 5G brings in all these flexibilities and a lot of thrust for creating quality products can be emphasized using these use cases. The third one is remote robotic operation, and we clearly see that this use case is not possible over other media things, other types of media, or other types of technology, because remote robotic operations is required in first of all areas where there is a difficult terrain. It can be a chemical plant, it can be a nuclear plant, it can be an oil and gas plant where there is a risk to human capital. And how we can avoid risk to human capital is by allowing robots to work in those conditions. In mining, deep pit minings, you have a danger of having a leakage, gas leakage in the mine areas. Instead of sending humans directly, you can send a robot first with the gas sensors, with the communication from the direct communication established with the backend. And these robots can identify the situation, the demography there first, and then humans can enter those areas, difficult areas. And in terms of operation into chemical or nuclear plants, how these robots can lift and shift kind of operation they can do, where somebody sitting from outside, maybe some kilometers away or maybe across a city, can use the haptic glove, can use robotic arms to navigate these robots, which will have latencies of response time requirement of say 10 to 15 milliseconds again, and a 5G network can very well achieve this. So again, this is a big area where you are saving the human capital, you are avoiding the risk, and you are contributing towards operational efficiency as well without risking the life. I have covered this. Now, in terms of say latencies, we have seen that the latency of 4G with fiber and with 5G. With 5G, you almost get similar fiber kind of latencies. Video analytics is another horizontal industry use case. It will work in manufacturing. It will be required in automotive plants everywhere. And I talked about this. There are examples. It can work on airports, ports for counting as covered in Vodafone slides as well. It can count people, number of people. It can count the areas which are. Sorry, Mr. Ashok, you are trying to say something.
Madhurji, if you can quickly.
Sure.
Yeah.
So I think this has been covered. I'll sum up. And there is a digital twin kind of a use cases which definitely helps in achieving operational efficiency by creating a digital model of your operations. So areas like digital shipyards, etc., where you have a huge lot of sensors, but you also have to have a very summarized view of your operations in the shipyard area and immediately want to address the areas where there is a notification or there is an alarm. So this also helps in scaling the number of devices that can connect to the network in a very efficient manner. So thank you. Thanks for allowing us time, and it was pleasure presenting here and understanding the views from others as well. And I hope that this will create a way to further interaction with the industries and taking these use cases for commercialization. Thank you very much.
Thank you so much, Madhurji, for at last moment you came and presented the use cases from Airtel side. Thank you so much. Now we are at the end of our webinar session. So now we have at the end we have vote of thanks. So may I invite and request our DDG Shri Adhir Kumar Singhal sir, DDG Training Management from NTI PRIT for formal vote of thanks. Over to you, sir.
Thank you, Ashok. And I'm humbled and honored by giving this opportunity to propose a formal vote of thanks, especially in a webinar of this great quality. the 5G use cases in manufacturing and logistics sector is something which is very, very crucial at this point of time. And we had some galaxy of speakers from academics as well as from the industry, which actually has fulfilled the objective of this webinar in more than many ways. To start with, I'll express my gratitude to Shri Nizamul Haq Sahab, Member Services DCC, for inaugurating the webinar and sparing his valuable time to inaugurate this. Sir has been very kind and always give blessing to the all efforts of NTI-PRIT. Thank you so much, sir. I also like to thank Shri UK Srivastava Sahab, our DG NTI-PRIT. He is the man who actually has given a new kind of direction to the NTI-PRIT. We had moved much ahead than what we were earlier under the leadership of Shri Srivastava sir, and all this quality and the quantity both. It's difficult to maintain quantity as well as quality, but he is able to do both. And we are so thankful to have you, sir, and setting the tone of this webinar by your opening address. Thank you so much, sir. My thanks go to TSDSI also for collaborating with NTI-PRIT for conduction of this webinar. And then I'd like to thank our learned speakers from academia as well as industry, Shri Professor Brijesh Lalji, Professor Arzad Alam Saab from ITI. They had set the tone by giving right kind of background of this 5G technology. And thereafter, Shri Baburaj from Nokia has given us a lot of good inputs about the use cases. Mr. Rajiv Sulaja from Jio, he's an old friend, and I was very happy to see him. And the way he has given us insight that how this 5G use cases can work for PM Gati Shakti was very, very relieving. Thank you so much. Mr. Amit Rao from Vodafone Idea for making us aware about that inventory intensive use cases about the video, etc. is thank you so much. Mr. Abhijit Chaudhary from Neural Network to convey the emerging applications and giving concept of the private 5G, which is going to be one of the things for the future. Thank you, Mr. Abhijit. And lastly, Mr. Madhur Bhardwaj from Bharti Airtel, and he has, in a very short time, has given us the concept of the inventory and warehouse management as well as remote robotics. So we had a very wonderful webinar. I'm thankful to all the learned speakers. Finally, I'd like to thank the Wireless Access Division for organizing this webinar. They had been doing it continuously. Earlier, they had done for health and agriculture and the power sector. Now this manufacturing, the logistics sector. Thank you, Mr. Sunil Kumar, Mr. Ashok, and other officers of the Wireless Access Division. And last but not the least, the learned participants who were in large number attended this webinar to be there and appreciate the effort of NTI-PRIT. Thank you, one. Thank you all. Thank you so much.
Thank you, sir. Thank you so much. Now with my DG NTI-PRIT to conclude the session.
Thank you, Ashok. I have to only thank you, Vinay, Sunil, for producing a very wonderful webinar. And thanks also to all the esteemed speakers who have been very kind and joined this event and shared their knowledge and experience with all the participants. And last but not the least, I would like to thank all the participants for their active involvement. They have been asking a lot of questions. So please keep asking questions. NTI-PRIT will itself reply or send it to the experts for their reply. Thank you very much for this wonderful experience through this webinar. All the best to all of you. Thank you.
Thank you, sir. Thank you so much. Thank you, sir.